This is Sarah Brings of the Professor Podcast, the podcast of your professors, their research, and their academic lives here at St. Thomas. This week, we're delighted to have Professor Ling, who's an assistant professor in the Department of Civil Engineering. Welcome, Professor Ling.
Thanks, Sarah. I'm happy to be here.
So to begin, could you tell us a bit about your background and how that led you to your current work?
Yeah, so I got my undergraduate degree in civil engineering at the University of Minnesota here in the Twin Cities. And then I spent some time in Colorado doing my PhD there. And my field is in environmental engineering. And the thing I like about environmental engineering is you get to solve really complex, weird problems that involve a lot of different types of science. So there's chemistry, there's physics, there's microbiology, and depending on what sort of site you're at or what sort of problem you're facing, you might have to work with one or two or all three of them. So I think that's super exciting. After I got my PhD, I went into environmental consulting for 9 years. So I worked at a firm here in Minneapolis, and I worked with specific clients to help basically make dirty water clean. So we worked with some cities who had some groundwater that they were treating for drinking water. We worked with some industries that had dirty water that was washing equipment or from some of their processes and figuring out how to make it clean so they can put it back into the river or send it to the local wastewater treatment plant. So I really loved my job in environmental consulting, and it was fun to work on different things and get that experience. But after about a decade, I kind of was ready for something new in my life, and I've done some teaching in the past, and so I really knew that I liked teaching, and kind of wanted to come back and help the next generation of engineers figure things out and figure out what to do and how to make a difference in the world.
Thank you. And so today's topic, if I'm pronouncing right, is PFAS, which stands for something. Could you kind of break it down, the meaning a little bit?
Yeah, so PFAS stands for per and polyfluoroalkyl substances. So that's a lot of things. The main thing is substances. So PFAS are a class of chemicals. They are human-made chemicals, so they don't naturally occur in the environment. If we back up, there's fluoroalkyl substances, or the F and the A part. That's just a little bit about the chemistry. So alkyl means that they're organic compounds of a certain shape, and then fluoro means that they have fluorine atoms attached to them. So the structure of PFAS is lots of typically long chains of carbon atoms, and then you've got little fluorine atoms that are attached to them in different ways. And the reason that that's important is that carbon-fluorine bond is the strongest bond in nature. And so it's very difficult to break, which means that when you make things with PFAS, they're very durable. They have a lot of other really great properties, but it also means that once they get out into the environment, there's no natural method for them to turn into something that's not PFAS once they're there.
Interesting. And when you're researching these forever chemicals, as they are called sometimes, is there any specific questions you're trying to answer, or is there a specific approach you have to take when you're looking at these chemicals and the problems that they cause?
Yeah, that's a good question. And as an environmental engineer, we talk about, and I've worked with a lot of different types of chemicals in the past. So sometimes you have heavy metal problems, or you might have problems with other classes of organic contaminants. PFAS are unique in a few different ways. The first is they are so persistent and mobile in the environment. What that means is that once they're out there, they don't go away. Any PFAS we make and put into the environment today are basically going to be there forever. And that has different considerations when we think about the impact for future generations and intergenerational justice. Different considerations than pretty much any other chemical we've talked about before. The other thing that's really interesting about them is that they're very ubiquitous in the products that we use. So I don't wear the shirt very often, but this shirt was probably made with PFAS. My shoes might have been made with PFAS. They're in a lot of textiles, a lot of building materials, carpets, flooring. They're in a lot of electronics, or used to make a lot of electronics. They're in paper products, children's products, toys, cosmetics, sunscreen. Their uses are very variable and very wide, which means that it is difficult to phase them out of products on a general scale. There are some types of chemicals that we phased out of products before. For example, 20 years ago or so, we were really worried about the ozone layer and getting a hole in the ozone layer. And globally, we phased out the use of chlorofluorocarbons, which is this different class of chemicals, which was a challenge to do. But if we think about those were really only used in like refrigerators and cooling systems and HVAC systems. But if we think about PFAS are in almost all the products that we use today, trying to get them out of the environment is going to be out of the environment is challenging, but also trying to get them out of products is a lot more challenging.
What are the specific risks of PFAS?
Yeah, so we talked about the persistence and the mobility. Some of the PFAS have also been shown to be toxic at various levels. So there are a lot of studies going on right now to show how toxic different types of PFAS are. One complication with them is that they're very numerous. Depending on how you define them, they're somewhere between tens of thousands to millions of this type of chemical. So it's very difficult to understand what is the toxicity of the whole class of chemicals, because we really can only study the toxicity of one or two of them at a time. So there's that toxicity risk. To me, the bigger risk to humanity in general is this persistence issue. So the fact that we put it in the environment, it doesn't ever go away. It almost doesn't matter how toxic they are, because if they never go away and we want people to live on the earth indefinitely, at some point, we're going to have put enough out there in the environment that it's going to exceed toxicity threshold and become toxic, even if it's not that toxic to start with.
In your research, do you mainly focus on understanding exactly what PFAS are, or do you more focus on how to remove them?
There are a lot of people working on both those things. I don't actually work on either of those things. So I think there's a pretty good understanding of what PFAS are and some of their characteristics, and people are studying the toxicity of them, like I mentioned. There's also a lot of great people out there figuring out how to remove them from the environment. I was just at a wastewater conference a couple weeks ago, and there's a lot of really great companies, really great startups, and smart people working on coming up with methods to remove PFAS from the environment in a cheaper and a more effective way. What I really focus on is trying to help people make decisions about PFAS. So the understanding of the technical characteristics of ways to remove them, I think, is really important. But if we zoom out a little bit more and we think about how we as a society are managing PFAS, we cannot just focus on removing them from the environment once we're there. We need to focus on trying to limit how much is going into the environment. I wrote a paper earlier this year where I estimated how much it would cost to remove PFAS from the environment at the same rate that we're putting them into the environment, and the cost would be greater than the global GDP, which means we literally don't have enough money to remove them from the environment once we're there at the current rates that we're using them. We need to start using a lot less of them. So my research focuses on trying to better understand the impacts of that type of use restrictions on society and help people better understand how to do them. And then also with specific treatment applications, if we wanted to treat PFAS, say, in drinking water or in wastewater or in other environmental media, trying to understand which of those media and which technologies make the most sense from a triple bottom line perspective. And when I say triple bottom line, I mean the economic, environmental, and societal impacts. So often, technology vendors will come up with a technology that works really great to destroy PFAS or do a specific thing, and they're mostly focused on how well it works. But whether or not something is going to be useful and helpful in a real engineering setting is going to depend also on how much it costs. It's going to depend on the impacts to society. So how much is it reducing actual risk and exposure? And what does that cost-benefit profile look like across those environmental, economic, and social aspects?
Interesting. So do you kind of find yourself collaborating with people from a lot of different fields? Because I could imagine that people involved in public health and policy would also kind of be part of this issue.
Yeah, and I love collaborating across different fields. I did a lot of that as a consultant, and I think that's a skill that I really like bringing into my work. So I'm starting some work with a couple of professors in the Opus College of Business to help better understand these PFAS use restrictions and help companies better understand how they can phase PFAS out of their products. I'm collaborating with some technology vendors right now to help better understand for their PFAS treatment technologies, what sorts of energy use, what sorts of cost considerations, what sorts of applications do they make the most sense in. And I haven't been collaborating with people in the toxicology world yet, but I would like to build some of those connections as well.
Interesting. So what does the process of your research look like? Do you do experiments? Is it mainly based on collaboration? Are students involved?
Yeah, I do have some students working with me right now. I had 4 students working with me this summer. My research is not really an experimental type of research. A lot of professors do great work, like in the lab, actually measuring stuff and collecting data. My research is more using data and information that's already available and trying to ask interesting questions that help people make better decisions about it. So, for example, for this study where I tried to understand the costs of removing PFAS from the environment at certain rates, I looked at a variety of different studies that had case studies where someone had used something to treat PFAS and then had costs estimates from it. And then I applied those to different data on how much PFAS we are using and emitting right now. And then that got us to the estimate of how much it would cost to remove them at the rate that we're using and emitting them.
Interesting. Do you see this as, in the near future, could you see this becoming a growing field or a growing, more pressing issue?
I think we may have even passed that point. So there are millions of dollars being spent in the PFAS treatment industry right now. And one thing that has hit headlines recently is the United States EPA, which is the overall environmental agency in the United States. They recently released some limitations on how much PFAS can be in drinking water. So what that means is they're targeting 6 different PFAS, which misses a lot of them, but it's something. They're targeting those PFAS, and drinking water plants that are exceeding that amount need to install and build and commission and start up treatment plants to remove them under a certain level by 2029. So 5 years, which is actually a pretty short timeline for like designing, planning, engineering, building, and starting up a significant engineering project. Where I think we need to go with thinking about PFAS as a society is focus a little bit less on the treatment side and focusing a little bit more on the use reduction and source reduction of how much is getting into the environment. And Minnesota is in a really good place there because the state of Minnesota recently passed a law that is going to limit how much PFAS is in certain types of products starting this year. And then by 2032, all PFAS that's in products in uses that are not currently unavoidable will be excluded from sale in Minnesota.
And are PFAS an essential substance in many products, or are they just something that occurs?
That's a very good question that I'm not sure anyone has the answer to.
Interesting.
They don't occur naturally, but they are used in such a variety of things, and they're very useful. Some of the things they do, so they're water and grease resistant. So for example, if you have fast food packaging that's made from paper and you want it to be water and grease resistant, traditionally that was done with PFAS. Now it can be done with various sorts of waxes and other products. So there are a lot of applications of PFAS where we have the technology and we have the ability to phase them out. So things like cosmetics, food packaging, carpets, textiles, and there's various companies around the world that have been working to phase them out of their brands. There are other applications of PFAS where it's a little bit more challenging. So for example, PFAS are used widely in the semiconductor industry as part of the process for producing semiconductors. And I know maybe you've been following the recent political developments with trying to get more semiconductor manufacturing in the United States. So if we were to institute something in the United States where people couldn't use PFAS in semiconductor manufacturing, that has geopolitical implications of potentially disallowing the use of semiconductor manufacturing here in a way that's competitive with it elsewhere. So semiconductor manufacturing is one. There's also PFAS in a wide range of pharmaceuticals as well. So I think those require consideration of how much benefit do PFAS bring in that use versus how much negative do we see from the environmental impacts of them downstream.
And this is, I guess, slightly off topic, I would say, but there's been a lot of discourse over the internet right now about microplastics and everything being toxic and everything being cancer-causing and having extreme risks to your health. And some people call it fear-mongering. Do you see that discourse as being productive or being a little bit more just for the sake of discourse?
Yeah, I think some of that is productive in terms of having people be aware of the wide variety of chemical risks and other risks that are in our lives. But I think in many ways it is not necessarily productive because I feel like often people then will focus on one or two specific things. So maybe people are really worried about PFAS in their drinking water, or they're really worried about microplastics in their food. I think helping to understand all those different sources of risk is important, but I think it's even more important to zoom out and think about risk holistically. So as a human being living in a Western society, I'm drinking water that's been treated at a drinking water plant, I'm eating food from somewhere. Those are probably my main ways to get chemicals inside my body. But I'm also inhaling dust from different things. So understanding kind of where the sources of exposure are and what the relative contribution of exposures are. So if we think about PFAS in drinking water, that's actually less than 10 or 20% of how much PFAS gets into most people's bodies every day. Most of the PFAS that people get comes from their food. That comes from pesticides and food packaging and other things. So when we spend a lot of money as a society to regulate and control PFAS in drinking water, that's money that we're not spending to reduce and manage it in people's diets, which is actually a much bigger source.
Is there any specific policy or practice that you would recommend to eventually phase out PFAS from everyday life?
Yeah, and this is a really difficult question. I think the work that is being done in Minnesota by the Minnesota Pollution Control Agency to implement this ban passed by the legislature, I think this is a really good start. Maine and Washington both have similar practices as well. I think other states and other jurisdictions are kind of waiting to see how things go here. There's a lot of complications to this type of rule. The first is that most people or most companies that use PFAS in their products don't necessarily know where they come from. It's kind of a supply chain issue. So if you have a product that's made from components that come from a bunch of different suppliers, you might have visibility maybe into your first tier of suppliers, but you probably don't know who's supplying them, or who's supplying the people who are supplying them. And so people actually understanding how much PFAS is in their components that they're using in their products or in the processes that they use, that's one big challenge. And I think Minnesota is helping to address that by requiring people to report that. And so people are going to have to do a little bit of learning to figure out how that goes. The other thing that I think is really complex about this type of use restrictions is what we mentioned before with how many of these are essential uses. So the Minnesota Pollution Control Agency will be considering applications for that currently unavoidable use. And so the process by which they accept those applications and consider them and try to decide which sorts of things they're going to provide an exemption for and which sorts of things they're not, I think that process is very new territory as well. So I think it's a great opportunity here in Minnesota to learn about how this could go, and it could provide lessons for the rest of the world since we're such a leader in this space.
It's interesting how many different fields seem to be involved in this one issue, because you've already talked about policy and the state government and also just engineering in general. It's very interesting how many, I guess, people are involved in this one singular issue.
Yeah, and I think with a lot of environmental engineering issues, like we have the technical capability to clean water. We have the technical capability to clean air. Whether or not it actually happens in ways that benefit society depends a lot more on how much it costs and the policy that's incentivizing it, who's going to pay for it, who's going to benefit from it. So I think understanding all of those things and help communicating that across disciplines is really something that we need in both in the environmental engineering area, but I think in other areas too.
Do you, as an engineer, approach this issue a little differently than, say, like an environmental scientist or a public health expert?
That's a good question. I think, when I think of environmental engineers versus environmental scientists, I think engineers are typically trained in a specific area. So my area is water, wastewater treatment, and trying to figure out if there's a problem, then what's the solution? And so I think engineers are often more solution-minded, whereas environmental scientists might be better at identifying and characterizing the problem. So I think as an environmental engineer, I'm trying to look at the solutions and the problems and also thinking about how those solutions could get implemented, which is kind of more on the policy side. So I don't think all environmental engineers like that. I think that's partly my personality, is that I really like to zoom out and see the big picture and say, why would we treat it here? Why wouldn't we do it there? What's the big picture? And where can we best invest our time and money that's going to have the greatest impact for society?
Could PFAS potentially affect underprivileged communities disproportionately than others?
That's also a very good question. I don't necessarily have an answer for that. There was a study that came out a couple of years ago that looked at how many sites that have PFAS contamination are there and where are they located in comparison to communities that historically have more Black and brown residents. And they did find that some of those communities were more likely to be located near to a system like that. But one of the other things is most of our PFAS exposure comes from stuff that we buy and bring into our house. And if you want to go PFAS free and buy things that do not have PFAS in them, those are often more expensive. So, for example, if you want to buy organic food, that's a lot less likely to contain high levels of PFAS, that's more expensive. If you want to buy a rain jacket that's PFAS free, that's more expensive. If you want to buy shoes or something else that's PFAS free, that's more expensive. So I think there's definitely an economic disparity there in terms of who can choose to limit their exposure to PFAS through the things that they buy. I think the implementation of some of these use restrictions in places like Minnesota will help to alleviate some of that disparity, but the economic implications in terms of will everything just cost more or what will be the overall impact on the broader economy, I think some of those considerations are still unknown.
Interesting. And do you see yourself continuing to do this research about PFAS and water? Do you see that continuing in the future, or could you foresee yourself switching gears a little bit?
Yeah, I think PFAS is a really interesting question right now that a lot of people are talking about, and there's active regulation in. So it's an interesting area to be working in, especially when I'm spanning all these different disciplines. In the future, I think I want to pivot a little bit more into thinking more broadly about risk. So thinking about, with drinking water, what sorts of drinking water treatment improvements provide the greatest health benefit per cost. I also have a background in environmental microbiology. So my PhD work was in studying the types of microbes that cause concrete corrosion in sewers. So I have some interest in trying to re-spool that type of research. We had a product that I developed during my PhD that was a concrete additive that helps prevent some of that type of corrosion. So I think that would be interesting. And also I'm really into microbiology and microbes in general, which I don't get to use much in this PFAS work. So I'm as I go forward and kind of think of research projects in the future, I probably will be moving away from PFAS at some point and moving into some of those other areas.
Is there any advice you'd have for students that want to learn more about the PFAS issue? Because I could see students from all sorts of majors being interested in this.
Yeah, I think the Minnesota Pollution Control Agency has a PFAS in products website that walks you through some of the different bans and use restrictions that are coming on. I think that's a really good source. I think kind of learning about the EPA's maximum contaminant limit implementation is kind of interesting. There's some studies being done right now in Europe to help better understand kind of where the different PFAS pollution sites are and how much it might cost to remediate them. So that's a good source. But if you're interested in looking up PFAS-free brands, some brands that have phased out PFAS, there's a website called PFAS Central that has a good list there. And that's typically where I'll go if I'm looking to buy something new and want to find something that's PFAS-free.
So I know you talked a little bit about what Minnesota is doing. So if Minnesota potentially was able to restrict the amount of PFAS in our environment, would that be effective in reducing the PFAS we're exposed to as Minnesotans?
Yeah, so as I mentioned, most of people's exposure to PFAS comes from things that we buy and bring into our house. So if you live in Minnesota and let's say in 2032, when most uses are phased out, the things that you can buy at the store will largely have a lot less PFAS than they do now. So if you're taking that 80% of your PFAS exposure and shrinking that down by however much PFAS is getting removed from products, it's going to have a big impact on people's exposure to PFAS in Minnesota and in other places where those products are sold. If we're talking about the impacts on future generations, that depends a little bit more on like the global use and emissions of PFAS. So in that case, having use restrictions in Minnesota and Washington and some other places is going to have less of an impact in terms of how much PFAS we're making and emitting globally. The European Union has done a lot of really great work and has proposed a PFAS use restriction. They haven't implemented that. They're doing a lot of due diligence upfront where they're trying to better understand in each of these industries where PFAS are used, what exactly are the alternatives, how available are they, and what would be the socio and economic impacts of implementing those phase-outs. So I think EU will at some point have a use restriction as well. So that's a big jurisdiction, but without a US-wide implementation or a global implementation, I think it's a little bit challenging. There have been instances for chemicals. For example, we talked about the chlorofluorocarbons with the ozone hole thing. There have been instances where we have agreed globally to phase things out. I think the fact that there's so many PFAS and they're so ubiquitous make that a little bit harder, but I do hope that that comes at some point.
And I know you mentioned that with the amount of PFAS we're putting into the environment each year, in order to take out that same amount, it would cost more than the global GDP. So is there really any hope to successfully phase out PFAS?
Yeah, and so the cost that I mentioned is not associated with the phase out. It's associated with treating it once it's out in the environment. And so the fact that that cost is so high means that we really should be pivoting to those phase outs, where we're going to have a lot more benefit per cost that we spent to reduce how much PFAS is going into the environment. The other thing that I think people should bring a lot of hope to is that you're in control of the majority of your PFAS exposure based on the things that you buy at the store and bring into your house. I know there is a cost equity issue there, but that's something that people who have the funds to be able to make those purchases, to do PFAS-free things, have some control over.
Is there a few simple practices that we can do, like you said, to kind of make those personal choices to reduce our own exposure?
Yeah, I think looking up the brands that have demonstrated that they've gone PFAS free is a good start. So on that PFAS Central website, you can see brands for like dental floss and for clothing and for other things. And trying to buy those brands as you go through things is helpful. I think buying organic produce that doesn't have pesticides is a good step too. Using glass or metal containers rather than plastic containers in your home, using cookware that doesn't have PFAS in it. One of the types of PFAS use that most people have heard of is Teflon pans. So if you use Teflon pans, you're getting PFAS in your food, you're inhaling PFAS as you cook it. So PFAS-free cookware is a big thing too.
Great. Thank you so much for joining us, Professor Ling.
Thank you. It's been an enjoyable conversation.
To learn more about her work, you can find her on the St. Paul campus of the University of St. Thomas. The Professor Podcast is brought to you by the St. Thomas Libraries and made possible with the funding from the College of Arts and Sciences. I'm your host, Sarah Brings. The producers and library staff are Mary Davidson and Andrea Kepi. Thank you so much to our guests and to you, our listeners.